welcome to this video. Today we are going to do Advent of Code Day 8. And I'm really excited about this one. I think I will learn a lot of interesting things today. Let's just jump right into it. So here we have today's. The 7-segment search. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave is at the greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7 segments displays in your submarine are malfunctioning. They must have been damaged during the escape. You will have a lot of trouble with them, so you better figure out what is wrong. Each digit of the 7-segment display is rendered by turning off or on 7 segment named A to G. So here we have the segment display, and you see how you can render digits using this display. So to render 1, you use segment C and F, and 7 you use other segments, and so on. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on the signal wires A to G, but those wires are connected to segments randomly. Worse, the wire segments connections are mixed up separately for each 4-digit display. All of the digits within a display use the same connections though. So you might know that only signal B and G are turned on, but that doesn't mean that segment B and G are turned on. The only digit that uses 2 segments is 1, so it must mean that segments C and F are meant to be on. With just that information, you still can't tell which wire B or G goes to which segment C or F, but for that you need to collect more information. For each display, you watch the change in signals for a while and make note of all 10 signal patterns you see, and you write down a single 4-digit output value, your possible input. Using the signal patterns, you should be able to work out the pattern corresponds to which digit. For example, here you might have a single entry in your notes. The entry is wrapped here into lines so it fits in your notes, will be 1 line. Each entry consists of 10 unique signal patterns. A pipe delimiter and 4-digit output values. Within the entry, the same wire segment connections are used, but you don't know the connection, which connections they actually are. The unique signal patterns corresponds to the 10 different ways the submarine tries to render digit using the current wire segment connections. Because 7 is the only digit that uses 3 segments, dab in the above example means that render a 7. Signal D, A and B are on because 4 is the only digit that uses 4 segments. E, A, F means that you have to render a 4. Using this information, should be able to work out which combination of signal wires correspond to each of the 10 digits. Then you can decode decode the output value. Unfortunately, the above example, all of the digits in the output value C, D, F, E, B, F, C, A, D, B, C, D, B, F, E, B, and C, D, B, A, F use 5 segments and are more difficult to decode. For now, focus on the easy digits. Consider the larger example. Because of A1, 4, 7, and 8 uses unique number of segments, you should be able to tell which combinations of signals corresponds to those digits, counting only digits in the output values after the part pipe on each line. In the above example, you have 26 instances of digit that uses a unique number of segments highlighted above. In the output values, how many times did the digits 1, 4, 7, and 8 appear? So let's save this link here for a day 8 output. So this is the simple one, but I have already started to figure out how to decode the other numbers, because I think that will be a part of part B. But let's start with the simple first one here. We know that we need to figure out which one contains all 7 and then 4, 3, and 2 segments, and that should be the puzzle, first part of the puzzle. So let's start here by creating a new class in our directory. And yes, it's early. Let's see here. Day 8. Let's do that. Doom, 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 doom. String test. Like that. And then we go back to day 4, for instance, where we had these kind of setup. And we will copy a bunch of things here. Like that. Day 8. And I call this data. This line out like that, and I think we need to have a try around this as well. There we go. Now we have prepared everything. We don't need the first part here. So what we want to do now is copy. We want to copy this data first, here. So I have pipe and a new line. I don't think that the input data will have that, so we might need to fix that up. No, so the input data will not have this extra line ending here. So let's just remove that part of the equation. There we go. Now we have our data. For each line, we will split it on a pipe, string line array, and then we will have string input will be the line array first part, and string output, which is the information that we are interested in now, is our other part. Then we will do another split of strings. So output array is output split on space. And then we can do a regex here. So let's say space plus. String s output array if s length, let's do that, s length, and just print that out. So we should get a bunch of length, which is not 0, I guess. And then we want to have length 2, 3. Oh, the wrong problem. That was yesterday. So we have a bunch of ones. So that's not really that great. Oh, yeah, split on. Okay. Why do we have a bunch of ones? Let's go here and see what we get. So here we have the output E. That's not correct. I guess we need to have the pipe. So IntelliJ is very sleepy today. Let's see here. Perhaps we need to use, as that could be an OR, we need to do that kind of thing. So now we have a bunch of numbers here and we got a bunch of zeros, which we are not really interested in. So let's do int count 0, count plus equal to length, and if length is equal to 2, then we want that segment. So we will increment 1 more there, and if it's 3, we'll increment 1 more, so that's a 7. We also knew a 7, which is the 8. It has 7 segments. And we also knew 1 more. We knew the 4 has 4 segments. So 2 segments, 3 segments, 4 segments, and 7 segments are unique. So those we can just count. And if we do that, and then output the actual result, count. Let's see here. We want to count to be before the for loop here. So we get all the counts. Then we should have 26. So that was the value that they had down here. So what we're doing is counting 1, which is just 2 segments, GC in this example. We are counting 7, which has 3 segments. So 7 has A, C, and F, so that's 3 segments. We're counting 4, which has B, D, C, F, so that's 4 segments. And we are counting 8, which has 7 segments. So, and that we got 26. If we are switching over here to our data and running that instead, we should get a larger number. We got an index bounds out of bounds exception. Why do we get that? Okay. Input data. If line is blank, continue. Let's see if that helps. No. So let's see here. When does this get out of bounds? Line array. Oh, of course. We need to read the right data. Else we will get nothing really. So 301 is the output we get. So let's see if that is the correct value for our puzzle. Yeah, you get a gold star, I get a gold star, everybody gets a gold star. So let's go to part 2. Though through a little deduction, you should be able to determine the remaining digits. Consider again the first example above. After some careful analysis, the map between signal wires and segments only makes sense in the following configuration. So the unique signal pattern should correspond to the following digits. Then the 4 digits in the output value is decoded to this. Yeah, so here we have figured out all the values. We have 1, we have the 0, we have the 4, and so on. Therefore, the output value entry is 5353. Following the same process for each entry in the second larger example, the output value of each are determined to be. Adding all the output values larger than in this larger example produces 61,229. For each entry, determine the wire segment connections decoded for the 4 digits values and what you get if you add up all the output values. So this was what I want. This was what I expected this challenge to be, which makes me really happy, because then I can continue trying to figure this one out. So let's see here. We will use this model up here. So if we know a 1, which we do, and we know a 7, then we know segment A or segment 1, for instance. So I will call these from numbers. So we have, or I think we will have numbers starting with 0. So this would be the 0th segment, and B would be 1 segment, 2 segment, and so on, because that's how the array will be. What I will do here is having a number array, int num array. So that will be a new int with 7 positions. And I will try to deduce the different values with this array. So first off, I need a function that can take int array, give that back from get numbers, like that, and then we have a string input, and here I want to take this string input and then give each of the numbers a specific position in my array. So let's say for string, let's do that, num split everything. So here we want to have a number out, and I would say let's do a switch statement and on this, and just do cases here. So if A, then we can have this int num array new int 7. So if A, then the num array 0th should be a 1. Do a case here. Great. So that's 1. Now I think we could put those on one line. And just continue with B, C, D, E, F, G. 1, 2, 3, 4, 5, 6. So now we have all the 7 parts of the array. We could of course do this with a char and remove some values and so on in order to figure out the position, but this is good enough. So now I can take some input and get a number back in an array form. And if we do that, we can figure out what the different values are depending on the size of them. And I think we will do a new class called day B here or something like that. And day 8B. And just copy everything here to day B. Because we need to start over. I'm pretty sure of it. Let's see here, day B. Remove this giant window down here. And we will go back to reading with the for loop instead. Like that. And we still need this thing, but we don't need this thing or the count. So we have the input and a bunch of values here. So input split on string, this, for each string number. Like that. So now we will go through each number. We need to figure out how long it is, and we need to figure out what the array is. So, what kind of lengths will we have? Let's go over here and see. We will have 6, one that has 6 positions. Like that. We will have one with 2 positions. We will have one with 5 positions. And then we will have another with 5, 4, 5, 6, 3, 7, and 6. So we see here that we will have 3 with 6 positions. We will have 3 with 5 segments. And then we will have these that are unique, right? So that leads me to believe that those with 5 segments should be easier to figure out than those that have 6 segments. And we should be able to deduce them from the one that has 4 segments or so. So if we have this with 4 segments, yeah. So let's start here by so let's do 1. We have 1, we have 7, we have 4, we have 8. So that's the digits that we get if we have these kind of numbers. And then we will have a list of potential values. So that's 5 segments. Array list. So that's the one with 5 segments. And then we will have a list of ints with 6 segments. New array list. So if number length is equal to 2, then the 1 will be equal to get number of this number value. And if segments are 3, then we know that that would be a 7. If segments are, let's see, what was the other one? 3, 4, then we know that that's a 4. And the last one, if all segments are set, then we know that that is an 8. Like that. Else if this number is 5, else if this number is 6. Then we will have 5 segments, add, get number, like that. Well, let's do a map. Like that, or like that, integer. And we will have the reverse as well, so we can get at them easily. Reverse. Then we can do this kind of thing. Numbers, put this value and 1, and then numbers reverse would be the opposite. So we can convert back and forth. So we want to put more into this array as we go. And we want the 6 segments down here. Add get number. So, now that we have parsed all the numbers, I think we will have this as a function as well. Numarray, public static map int integer. Get map like that, perhaps. String inputs. So now what we want to accomplish is that this numbers array has all the mappings we need for all the numbers. So this numbers array currently, if we have done this correctly, should have missing return statement. What? Oh, This was the function that we never used. So that's okay. Let's go back here and run this one. And I also want to have get map input. Map int integer, like that, numbers, and then down here we can do a for loop of output split on space string, and we can do trim on that as well, so we remove all the extra spaces. I think we can do that with our first function as well. Let's do a trim here, just so we don't have any extras. So here we will take this string and get a number of this string, and then we will take numbers and get the actual value of that, and then we will take int let's see, that's a number in the sequence, so that doesn't really help us. We don't really want an integer, we want a string. We want a string. String output number. And why do we want a string? That's because a string could be used with a big integer, and that will give us the actual number without even thinking about what position they are in. So here we can take bi and get the int value, and then take count and add to that. And then up here we can add this count again, and count, print that out. So that's a very simple way of handling this, which means that this map should give us a string back, and we could handle strings here as well. That doesn't really change anything. We just need to remember that everything in all of these examples here are strings. String. So that's what we want to accomplish. And if we run this, null null, yeah. So that was expected, that we had a bunch of null values. If we go into this get map and go down here and run the debug, then we should have a numbers array with a bunch of valid numbers and their corresponding values here. And if we look at this array quickly, we can see already that we know which value is the one position, the top one, because 7 has 3 position, and this one up here, it's the A segment or whatever you call it. So we know that that is the top one here. What can we do with that? If we take this top one and put it on this 4, we almost have a 9. We are missing one part down here. So we need to find a number which has all the values except for this one down here. That could be one thing we could do. we know. What more do we know? What more do we know? Could we figure out any of 2, 3, 5, any of those by what we know currently? We know that segment, and then we know this is, any of these are the back hand. So we know that segment. We probably know B and D if we remove A from 4. So let's see, 5 segments. I wonder what's simpler here. We almost know a 9. Because if we add 1 minus 7 plus 4, 7 minus 1 plus 4, then we almost have a 9. And then we can know both of these segments. So let's do that. Let's create some functions here. Public, static, int array, add, a, int array a, int array b. So then we will just go for, or should we just add to the first one? Yeah, we do that. Void. So for position, I'm 7, I plus plus. Then we just take A, I plus B, I. And then we can have a subtract. And do the same thing here. So if we take the numbers reverse and we get 7, and then we will do subtract of 7 and numbers reverse get 1, then the int we get in the 7 array here, segment A, that's what we would have there. So let's see if we have segment A there. Because A is null. What? No. Oh. Get 7. So let's try that again. So now we should have segment A, which is just 1 value. If we then add a 4, to that. What do we get? We almost get a 9, right? Yeah. So now there are two values that are not set. And if we do like this, public static void similar and then we will have this list of ints values and then the ints that we want to find for each of these values how do we do a similarity score here? What's the easiest way? Let's do this loop again. Let's say v minus num int val equal to 0 if this is larger than 0 then add 1 else add 0 smallest 7 int smallest num like that. If val is smaller than smallest, then smallest num will be equal to v and smallest equal to val, and down here we return smallest num. So that's what we want to return. And does that work? Yeah. And then we will similar, and then 6 segments of this segment A. And that should be a 9. if I'm not incorrect. So this one thing here is probably a 9. And from this, we should be able to deduce which one is segment. Let's see which one is what segment. So we figured out that this one, G, we should be able to figure out G as well. Okay. So let's start with adding to our numbers. Put 9 into that and call it 9. And then we will put in the reverse as well. So we'll have 9 like that. We got a number more. We figured out 9. If we now take this segment A minus 9, we should have segment G. So if we remove 9 from segment A, then this new 9 should be segment G. If that helps us. Let's see if we get that. Yeah, so now we have segment G here. And if we know G down here, we know 4. We know what more do we know? If we have G, and we are back, and I ran out of disk space, which was a bit interesting, so the recording cut off there, and I just babbled on and handled each case in turn, and I think it's more interesting to actually talk about what I did after the fact than just seeing the full process, because I just continued on there. So you see here that I got the correct result for the test case. So if we go over here, you see that 61,229 is the correct result. If we switch over to the real data set and run that, we'll see if we get the right result there. Let's try it. And we got 908,067. So let's switch over here and submit that result. Yeah! You get a gold star. I get a gold star. Everybody gets a gold star. So that was the correct solution. So let's go into what I did. And I think we need to actually have this map up here. So you see this 0 and all these values. I will put that over here so we have those numbers. So what I did here, if we go a little bit further up, first off, we knew a couple of numbers. So I have this get map where I get all the numbers. We knew a couple of them, so we know that the one that contains 2 segments, that's a 1, so we put that in here. We know that contains 3 segments is a 7, so we put that in. We know that the number with 4 segments is a 4, so we put that in here, and 8 has 7 segments. Then I created 2 lists, with 5 segments and 6 segments, so I know the rest of the numbers. Now I just need to figure out what is which number. And what I did here is that I started to see if I can find 9. So we know a bunch of these numbers, and what I did is take number 7 here, well, now down here, and I removed the segment here CCFF from 1, so I only have these A's on the 7 left, and then I added the 4, and if we do that, this part up here will be set as well, and the only part missing is the one down here. So then I ran through and created a function called similar, which will go in and find the one number that is the most similar to the number that I'm looking at. So we look at 7 segments, and then I will look at each number, and if there is something left when I remove segments, then if there is a lot left, then they are not that similar. So I want that one that I remove the least from. And in this case, that was the 9. So the smallest one is, the smallest num is what I will return here to similar. And then I will get number 9, so I put that into number 9, and I will remove that from 6 segments. So now that we have 9, I started to think again, what can I figure out now? So 9 without a 1, so I will remove the right-hand side here. And if I do that, then that is very similar to a 5 over here. I remove the full 1, but FF is the only one that is missing. The rest is correct. So if I remove that, I could say, okay, that's pretty much very similar to 5. So I can actually change this out here so I know that I'm finding a 5. So find 5. And if I do that, I get a 5. Next up, when I have a 5, I looked at that and thought, okay, a 5 is very similar to a 3, except for the other end here. So if I take a 5 and remove a 4, which is this one over here, then I will remove B, D, and F, so I only have the roof and the floor left. And if I add a 1 then on this end, then the only thing missing is the DDDD here. So I can check similar and get a 3, put that in, and then I have removed all but 1 in the 5 segments, so the one that is left should be a 2. So now I have only the 6 segments left to handle, and I only have 2 values left. It can either be a 0 or a 6. And if I look here, if I have a 2, if I take the 2 and remove a 4, then I will remove D, D, and C, C. So that end up on this side here. B, B, and FF will be left, but I remove those segments that is in a 4. Then I will only have A, E, and G. And if I add a 1, so I add C and F back again, then the only segment over here that is missing is B, and that's very similar to a 0, and not really similar to a 6. So if I find similar there, I will find a 0, and the last number I will have left is 6. Adding, I changed that function up a bit, so if I add something, I only want to add up to 1, so I will add more segments, but not so I get 2 or any number like that. The same goes for if I subtract something, I don't want minus values, I only want 1 or 0. So I just added some extra functionality there. So now that I have all my numbers map here, I can take that, and then for each of the output values, I will get the specific number in the functionality that we had up there with the switch statement. And when I have that number, I can get the hashed map value of that number. I started off actually having just numbers and then get the num from there, but I got null every time. So hash map seems not to work that well with int arrays as keys. So I had to improvise a bit, so I created this hash map value, get hash map value. It takes this map that we have and then the value we want to look for. And the only thing I go through all the entries and checked if the arrays are equal, the key is equal to the value array. And if so, I will return the value. And I will return empty string if I don't find anything. I didn't have that problem, but I added it here. I could have null as well, and then I would have got an error if that was the case. So this day's issue was pretty fun. It was finding similar structure in a number and what you can subtract or add in order to find other numbers in the sequence. This is how I solved it. You will probably have another solution, and I'm really eager to see that, so put that in the comment section down below. If you haven't subscribed yet, please do that if you want to see more of these puzzles solved. And if you like this video, give it a like, share it with your friends and colleagues, and I really hope to see you in the next video.